The example, the example of confounding that we're going to discuss comes from a very basic example, and this is the relationship between coffee and CVD. Obviously, CVD is the outcome variable, and coffee intake is the exposure variable, yani the deep independent variable. When you look at these two variables, you may have a situation where it appears that there is a relationship between the two, meaning that it seems that those that actually those that consume coffee, appear to have a higher prevalence of CVD. Yani as if there is a relationship, a positive association between drinking coffee and having CVD. Then you investigate the potentiality, the possibility that there's a confounding, and here we're thinking about smoking. Well, if you remember, there are three criteria for a confounding to be a potential confounder. First, is it related to the outcome? Is it related to the exposure? That's number two. Number three, it shouldn't be in the causal pathway. Let's think about smoking. Is smoking associated with CVD? Obviously, the answer is yes. Is smoking associated with coffee intake? And the answer is yes as well, because those that drink coffee appears to consume smoking to smoke more than those that do not consume coffee. And the last question is smoking in the causal pathway between coffee and CVD. And drinking coffee causes smoking, which causes CVD, and the answer is no. And therefore, smoking meets the criteria for a potential confounder. It could be a confounder. And then it has to be investigated to see, is it a confounder? And yes. And the following slides, I'm going to show you how you investigate if it's a potential, if it's a confounder or not. So first, we have established that it's a potential confounder. We found out that it's related to CVD and it's related to coffee, and we know it's not in the causal pathway. Then the following thing is to try and figure out, is smoking confounding the relationship? And the answer to that, which is, I'm going to give it to you right now, and then you're going to see how is that. The answer is yes. In fact, coffee and CVD are not related. There's no relationship. But because both of them are related to smoking, because of smoking, they appear to be related to each other. Therefore, smoking is doing the type of confounding where no relationship appears to be existent. So let's look at how you try to investigate the relationship between the two. Okay, so first thing you do is you're going to look at the exposure and the outcome. Remember, the exposure is coffee, the outcome is CVD, and you're going to put your data in a contingency table like this one. The exposure variable here, the outcome variable is there, and then you start asking the question is, if I look among the coffee consumer, what is the rate of CVD? The answer is 215 out of 400, yani 53.75. All right, what about those that do not consume coffee? What is the rate of CVD among these people? And the answer is 90 over 400, yani 22.25. Therefore, after you look at these two numbers, you say, okay, the coffee consumers have 53.75% CVD. The non-coffee consumers have 22.5% CVD. And therefore, you would reach the conclusion that it seems that CVD is the prevalence, the occurrence of CVD is more than double in the consumers of coffee than in non-consumers, and therefore reaching the conclusion that there is a positive relationship. That is the apparent relationship that exists between the exposure and the outcome, and that is the relationship that needs to be investigated if it's confounded or not. We haven't done that yet. We're just looking at the relationship regardless of the confounding first. Okay, now before I continue, I want to point out that in blue here, I have addressed the same idea in red, but I'm using what is called the odds ratio, which we will cover in the coming lecture. But if you haven't seen this lecture yet, don't worry about it. You can come back later on to it. But basically, I'm just going to say what the odds ratio is saying here. Well, we get a odds ratio of 4, meaning that there's a strong positive association between coffee smoker. I'm sorry, between coffee consumer and CVD. Okay, then what are we supposed to do next? Next, what you're supposed to do is you're supposed to look at the same exact analysis, yani the relationship between coffee and CVD, the relationship between independent and dependent variable, but for subgroups of the confounding variable. What is our confounding variable here? It is smoking. So therefore, you're going to split your sample between smokers and non-smokers, like I did here. So I have my non-smokers here and my smokers here. And then I'm going to repeat the exact same analysis I did, where I'm going to look again at coffee and CBD, but I'm going to look at it once in the non-smoker group. And again, I'm going to look at coffee and CBD, but this time for the smoker group. And I'm going to see what's going to happen. But as a note, that just so that you see I'm not making up the numbers. So you can see that the 400 coffee consumer got to be split into 50 in the are coffee smoker, but in the non-smokers, and 300 come in coffee consumer, but in the smokers. Okay, so any of these 6 cells is split into the 2 tables and the numbers add up. All right, so let's see what happens if I only look at the non-smokers. Again, I'm not interested in the relationship of smoking and CBD. I'm still interested in coffee and CBD, but within a subgroup يلي هن non-smokers. So in the coffee, 5 out of 50 يعني 10%. In the non-coffee consumer, 30 out of 300 يعني 10%. Therefore, if you consider non-smokers, CBD occurs in 10% of the coffee consumer and 10% in the coffee non-consumers. Therefore, if a person is a non-smoker, whether that person takes or does not take coffee, it's not going to do anything to their CBD. Yani, in the non-smoker, there's no relationship between coffee and CBD. Okay, same idea repeated here using the odds ratio, which is equal to 1, and therefore there is no association. Okay, well let's look at the smokers then. Okay, so here's my smokers, and I'm going to look at the CVD occurring in the coffee consumer, 210 out of 250, and 60%, compared to the non-coffee consumer, so it's 60 out of 100, come in 60%. So if you are to look at those that smoke, whether they drink coffee or do not drink coffee, it doesn't do anything to their coronary heart disease. So what we're seeing is the following. Considering non-smokers, whether they drink or do not drink coffee, that doesn't do anything to CVD. There is no relationship between coffee and CVD. If you consider smokers, if they take coffee or they do not take coffee, again, that doesn't change anything with regard to their CVD. So no relationship between CVD and coffee among the smoker. No relationship between coffee and CBD among non-smoker. So it should make sense that there's no relationship between CBD and coffee. However, when you put them together, an apparent relationship appeared, which is a fake relationship, a confounding relationship. In fact, the true relationship is that there is no association between coffee and smoking. And therefore here smoking is confounding the relationship between coffee and CBD by making a non-association appear as if it exists. Remember, confounding can do multiple of things. It can make a no relationship appear as if it exists. It can make a relationship that does exist to appear that it does not exist. It can make weak association appear as strong appear as weak. Remember all of this? Well, the example we just covered here is the example where a no relationship is appearing as if it exists because of the confounding. So to conclude, the exposure, the independent variable, it was coffee. The dependent variable, the outcome variable, was CBD. There's no relationship between these two, but because of smoking, which is a confounding variable, it was confounding a relationship between the two and making as if the relationship appears between the two. So how do you address confounding? You have 2 major approaches in addressing confounding, either in the analysis or in the design. In the analysis, one way is to do exactly what I did here, معناتها doing a stratified analysis. There are other statistical techniques of analysis, like the multivariate analysis, that can also address the confounding, but we're not going to address them here. In the design, also you have techniques that can address confounding. It's restricting, matching, etc., etc., propensity score matching, etc., which you're not responsible for, but I'm just mentioning them so that you realize that there are ways that you can use to address confounding, which we will talk about next year in P3. Okay.